As I mentioned yesterday, if the theorem has its own name, it's going to be important. This is our first, I think, named theorem called Intermediate Value Theorem, also known as IVT. You've used this before, you just didn't know it. And it's based on a simple concept, which I'll explain on the following slide. It has to do with growth. So when you were born, you had a certain height. I don't know, 21 inches, let's say. And now you might be, let's say, how tall are you? Okay, so you might be 6 foot. In that time span of X number of years, he has been every possible height between 21 inches and 6 foot tall. Okay, you can't just jump over height, and that's an infinite concept. Okay, so we have a tendency to think in integral values, 5'11", 4'2", etc., etc. But you have all covered that infinite number of possible heights because you just don't jump from one height to the other, okay, which is explained in that slide. I'm not going to insult your intelligence by reading it to you, but I pretty much just summarized that. When you grow, you cover every height from the starting point to the ending point on some interval. So this one happens to be 5 foot to 5'7". By the way, this girl's knees would be destroyed if she grew 7 inches in a year. She would be like a baby giraffe. But you understand the concept, yes? So now we can translate that into a mathematical approach, which says that if you have a continuous function, I have a picture of one right here. If you have a continuous function and it goes from some y value, in this case 1, to some other y value 5, it's got to cross every value in between. But you'll notice the stuff in the blue box, which it must be important, it's in a blue box, it starts with f is continuous. So one of the things you have to absolutely remember is the fact that that function must be continuous. You'll either be told that information or you'll have to determine if it's continuous. Okay. Also notice that little tidbit in there that says f of a is not equal to f of b. Okay. You can't start and stop at the same height. Even though if you actually look at a growth chart for humans, you do start to shrink at a certain point. And so I'm 6'2" now. By the time I'm 80, I'll probably be 6 foot. And I'll be like 3'6" by the time I die. Does that function look, or does that concept look understandable? Okay, good. It didn't intend it to be rocket science. Now, what do we use that for? Most commonly, we use that to find zeros of a function. So I have an example for you. Let's suppose we're looking at a cubic here. What can you tell me about that cubic? Good. What else? Did you doubt yourself just because I had to look at the function? Oh my God, I'm wrong. It'll be the worst thing ever. Anything else?
It's continuous.
How do you know that?
It's a polynomial.
Beautiful. Okay, that's crucial. Wow, this is just like a love fest, isn't it?
Good job.
It's a polynomial. And if you picture in your brain what you think a cubic looks like, you can understand that we could get a variety of answers here. It might intersect the x-axis in 1 point. It might intersect the axis in 2 points. It might do 3. I don't think it can do more than 3. In fact, I'm sure it can't do more than 3. What the intermediate value theorem will do for us is allow us to prove that, yeah, it crosses the x-axis at least once. That's it. That's all it does. It won't tell you where it happens. It won't tell you if there's more than one. It just says it's going to cross at least 1 point. And it looks something like this. First of all, as we already did, we have to establish that the function is continuous. And as JJ said, we know it's continuous because it's a polynomial, and all polynomials are continuous. Then what we need to do is figure out where it starts and stops on that interval from 0 to 1. So if we're on the interval from 0 to 1, where does that function start? -1. How'd you get that? 1, 0. Where does that function end? 2. Plug in 1. Now we know our starting y value and our ending y value. Since one of them is negative and the other one is positive, we know that somewhere along the line it has to have a value of 0. Okay. Which is fairly easy to show. We found f of 0. We found f of 1. Since f of 0 is negative and f of 1 is positive, then we know that it has to cross the x-axis somewhere between 0 and 1. And again, notice it doesn't tell us where that is. That's for a later problem. It just tells us, yeah, it happens. Okay. By the way, that's called a sign change, fairly common. Negative to positive or positive to negative. Anything tricky about that? We're good? You sure? Excellent. In that case, we're done. Yes, it's just that quick.